All right. I hope all of you are back on your seat and we can start with the second half of our session today. So I would say let's start with the topic and let's start with talking about Boolean operation. So first of all, the question is, what is a solid body? So a solid body is a geometry that has a volume. So you already know our basic feature elements. So for example, something like this block, this cube is a solid body because it has a volume. So if a geometry is closed by surfaces, you can define the material inside the surface provides that the geometry is a solid body. This is one point. The other point is the magic behind the visualization of solid bodies or solid body is the combination of several simple geometries like a cube or a sphere. The computer automatically calculates the visualization through unit, abstract or intersect simple bodies. So this is math, of course it's math, but in the heart of this technology, the computer works with simple geometries like a cube or a sphere, and with these simple geometries he visualized complex geometries. So now the question is, what is a Boolean operation? Not only the computer can realize bodies by using unit, abstract or intersection operation, you can also use you can also realize complex bodies by combining of several simple bodies. This workaround is called Boolean operation. Nearly all modeling tasks require this workaround. On the left side, you can see a pretty easy example for this workaround. So on one hand, we have our block, so this cube over here, and on the other hand, we have our sphere on the right side. So first of all, it was two separated bodies, and with the workaround by using unit, we have only one body. So we combine the block with the sphere, and maybe as you already know, it would be extremely complex and extremely hard to create geometry like here with only one sketch. So a geometry like this you can only realize by using the Boolean operation. So the Boolean operation is a very helpful and powerful tool for creating complex geometry, and I can promise you, you must be familiar with this tool to be successful in the world of product development. All right. So what types of Boolean operation are available? So more or less you can find 4 types of Boolean operation in Siemens NX. So the first one is the unit one. The unit one you can see on the left top side. So unit one so for Boolean operation you need always 2 bodies, and with the unit function you can add a current solid body to another existing body. So maybe to explain it, so we have this rectangle which is extrude in the Z direction, and as a second body we have this cylinder, and the box and the cylinder is unit to only one body. And the result you can see in this picture on the left top view. The second type is abstract. So in this case, we don't add material, we cut material away. So the abstract type, abstract currently solid body from another existing body. So the result you can see on the top right side in the picture. So now some material in this area is missing. The next one is intersection. So it's a special one. So we have two bodies, and this one realizes an intersected solid body between two existing bodies, and the result you can see on the left top, on the left bottom side. So this is the intersection. The last one, it's a special one from Siemens NX, is the one none. So nothing. More or less, it's not really a Boolean operation because Siemens NX doesn't do anything. So none is a special type of Boolean operation, and it's required by future tools like extrude or revolve. So the none option creates a new and a separate body. If you take a look on this picture, so in this area, here you can see that are two separated bodies. So to compare these both, so in this area, you can't see the contour of the cylinder. If you take a look in this one, you can see the contour of the cylinder. This is a result because that are two separated bodies. So to summarize the slides, in Siemens NX you can find 4 types of Boolean operation. One important point, the Boolean operation have 2 requirements. So the following requirements must be met to realize a Boolean operation in solid modeling. So the first one is the target body and the tool bodies must be solids. So there are different types of bodies available in Siemens NX. The first one is the solid body, and the second one is sheet body. So a sheet body has no volume, so it's something like a paper, and you can't do a Boolean operation with paper, so it must be a solid body. The second one is the solid bodies to be operated on must have a common volume. If you try a Boolean operation between separate solid bodies, an error message is not displayed and bodies are still separated. On the left side, you can see this case. So we have our block over here on the left side, and we have our spare on the right side. And if we take a deeper look into our part navigator, you can find the future unit. For this one, maybe you could think, oh, I did the unit tool, or I used the unit tool, but the result is the 2 bodies are not one body, they are still separated and they are still 2 bodies. So in this case, be careful, and it's a problem from Siemens NX because an error message is not displayed. All right. So let's talk about the workaround, about the process. There are two possible ways. The first one is direct in the future dialog box. In a few minutes, we take a look into the future dialog box. And the second one is that so this is called direct way. So if you use the possibilities of the, or if you use the options of a future dialog box, for example, the future dialog box of extrude or revolve, this is called direct way. And the second one is the two-step ways. So you create two bodies and then click the button on the base icon group, select your target body, and then select your tool body. And if you are fine with both, press on OK. Another important point for you, let's talk about the part navigator. In the last couple of sessions, we are always work with step order. So you have two different, there are two types of orders. The first one is the time step order. So in the time step order, you can view the feature and modeling history. So it's like this one, you already know this view. Another important view or another important order is the second one, the body order. In the body order, you can view the bodies. And this is very important in context of Boolean operation. In this order, you can check if you have really only one body or if you have several different bodies, and these bodies are not unit, they are separated from each other. It's very important to switch between both, between time step and order, or time step order and body order. All right, this was a lot of theoretical knowledge. Now I would like to demonstrate these points in Siemens NX. So I switch back to my Siemens NX. Please give me a second. Give me a second. All right. Now you should see Siemens NX. All right. Let's create a new part, new one. I would like to go model. I'm fine with this name and this folder as well. So I pressed OK. Now, first of all, I create a cube. So first I clicked on sketch. I go with the top plan. OK. I create a rectangle. I go with this option. I select the 0, 0 point as the center point of my rectangle. I'm fine with this contour. Now I have to define the diameter. So I pressed on rapid dimension, select the first one and the second one, double click, I don't know, 100. And another one is maybe only 50. All right. So now all lines are colored in black and the inside surface is colored in blue. So I'm fine with this contour and with the sketch, and Siemens is fine with this sketch as well. So I can press on finish. Now I can extrude this section. I'm fine with, I think, 50. Okay. So now let's take a look at our part navigator. So on the left side, you can see our part navigator. You can see we have one sketch and we have one feature. In this case, it's the extrude. So the order you can see here is the order, it's called time step order. Now I would like to know how many bodies I have. So I must switch this view from time step order to body order. How can I do this? I go with my mouse, I place my mouse over here. Then I press the right mouse and this dialog box is invoked. And then you can find this one, time step order. Click with your left mouse on this time step order. And as you can recognize, the view is changed. Now I can't see my sketch and I can't see my extrude feature. I can only see my bodies. And as you can see, I have only one body, and that is what I have at the moment. So I'm fine with only this body. All right, let's switch back to the time step order. So I placed my mouse over here, pressed my right mouse, and click again on time step order. Now the view is changed and now I can see my sketch and my extrude feature. So I do another sketch. So I pressed on sketch, reset. I choose the top plan. Okay. Now I add a circle, for example. So I place it over here. Now I have to diameter this circle, so I select rapid dimension, reset, press this one, then this one, and maybe this one as well. So this one should be 0, so I'm fine with this one. This one should be, I don't know, 50. And this one should be 30. All right. All lines are colored in black. The inside surface is colored in blue, and Siemens NX is also fine. So I can leave this sketch environment. So I pressed on finish. And now I extrude this section. So I press on extrude, reset. Then I select the curve. And now we come to the first way, to the direct way. Here you can find the section Boolean. And here we have several different options. The first option, maybe first of all, let's change the distance from 25 to 50. Let's show. All right, so now we are none. So if I click on OK, so if we take a look on the left side in my part navigator, I have extrude twice. So this is for the first component, the orange one, and this is for the second one. If I'm not pretty clear how many bodies I have, I can change my part navigator from time step order to body order. So I placed my mouse over here, press the right mouse and select this one with the left mouse. And now, as you can see, here we have two bodies. So this one is the first one, and this one is the second one. All right. So now I know I have two bodies. Now I would like to have only one body, and they should be together. So they should be unit. In this case, I switch back to the time step order. So I place my mouse over here, right mouse, and select this one. Now I want to do it on the direct way. So double click on this one. And now I have to change this option from none to unit. Here Siemens NX automatically select the second body. So I pressed on OK. Let's go again back to the body order. So I place my mouse over here, right mouse, and select this one. Now, as you can see, I have only one solid body. Now I would like to subtract this body from the other body. So double click on this one. And now instead of unit, I go with subtract. And the result you can see on the screen. And let's go to the body order again. So I place my mouse over here, right mouse, selecting this one. And as you can see, it's still only one body. If we want to create the intersection of both bodies, do a double click on this one. And instead of subtract, go with intersection. And here we go. Here you can see the result of the intersection operation from these both bodies. And again, let's go to the body order. So I place my mouse over here, right mouse, select this one. And as you can see, there's only one body. So as a reminder, if you do Boolean operation in context of this dialog box, we called this one direct way. So please keep it in mind. This one, it's called direct way. Direct way. Okay. Another important point, as I already said, let's talk about the requirements. So of course, let's do it. I change this option from intersection to none. Let's switch to the body order. And one requirement, or the first requirement, was both bodies must be solids. And as you can read, this one is a solid body and this one is a solid body. So we achieved the first requirement. Now we have to achieve the second requirement. So the first and the second body must contact each other. So in this case, we also achieve the second requirement. Now I would like to show you if we can't realize this requirement. So I modified my sketch. So I do a double click on this sketch. And now instead of 50, I go with, I don't know, 80. So let's take a look on both bodies. Both bodies are not really have a relationship. They don't touch each other. So they are not really aligned to each other. And so let's take a look. So I think both are bodies. So let's take a look into our body view. So yeah, solid body and solid bodies. So the first requirement is achieved. The second one, Not really. So let's do to unit both with each other. So double click on extrude and unit. So he selects this one, the orange one. Okay. Yeah, let's take a look into our body order. There's not really a relationship between both bodies. So the bodies are still separated. So please keep this in mind. Let's change this one from 80 to 50. And change this one from unit to none. So as I already said, that was the direct way. Now I would like to show you the two-step way. So the two steps away is to use the unit tool over here. So instead to do the Boolean operation in this command, you also can use the two-step way. So please select unit over here. And then you have to define the target body. So this one should be the target body and this one should be the tool. And then you can click on OK. And now you can see it over here. Now you have the function unit in your part navigator in the time step order. Let's switch to the body order. So I place my mouse over here, right mouse, and click on here. And as you can see, it's only one body. Same workaround with subtract. So I delete this one. And now I go with subtract. I select my target body, I select my section body, and I select my section body and press on OK. Now, as you can see in my part navigator here, you can find the subtract function, and over here on the right side, you can see the result. And again, let's switch to the body order. And as you can see here, you have only one body. So let's switch back to the time step order. A question from you can be, where can I find the intersection feature? Because you can't see this function over here. It's a great question. One way would be to take a look over here. And then you can select here intersection. Another way is to use the finder. So enter intersection and select this one, and the intersection dialog box is invoked. All right. To summarize this one, you have two ways of to do Boolean operation or to use Boolean operation. The direct way is to use this option. This is called direct way. And the two-step way is to go with this feature over here. Yes, it's up to you which way you use. Both way has his pro and cons, of course. Yeah, it's more or less something like an experience. Some people go with the direct way, and some people prefer the way with the two-step way. All right. Do you have any questions to the topic Boolean operation? All right. So now it's your time. It's not the same task as the last task. Now, more or less, it's the same drafting, but now the task is first extrude the main corner of this main corner with an end limit of 6 millimeters. So what I mean with the main corner. So the main corner is the outside lines. This one. This should be the first sketch. Only the outside line. Not the inside, only the outside. Then extrude this section with an end limit of 6 millimeters. And then realize the 3 holes with additional futures. So, well, in the second step, you should realize this hole, and this hole. And use the Boolean operation and use the direct way. As a reminder, the direct way is the option in the extrude involved box. Or in the again, as a reminder, the direct way is to use the option in the extrude dialog box. So yeah, please start with this exercise and please do it on this way as you can read on the right side. I will upload this exercise into Teams so that you can download this exercise, and please start with this exercise. So now you can find the exercise in our team channel. All right, some of you are already done with this task. Now I would like to show you my way of modeling. To save a little bit of time, I always create this first part of this task because we already talked about how you can realize the outside of this component. So now in the next step, I have to realize all holes in the inside of my component. For this, I need a second sketch. And here, as a small reminder for you, I gave you the hint to keep a sketch as simple as possible. And in this case, one way would be to create only one sketch for all 3 holes. The better way, and the way I can recognize to you, is to create 3 additional sketches. So this has the advantage that if there are any change of one hole or something, you have only to delete this sketch and the extrude command. I will come back to this point a little bit later. So I start with my first sketch. So I select the sketch and I want to sketch on top of this surface of the red surface. So I pressed OK. So first of all, I would like to create the circle over here. So I select the circle option, go with the option circle by center point and diameter. Then I select our 0, 0 point, which is over here. So 0, 0 point. A random size. Then I select the rapid dimension and reset, select this one, close, double click on it, and change this random value to, or instead of this random value, I go with 22.5. Enter. Yes. All right. And now all lines are black, are colored black. The inside surface is colored blue. Siemens NX is happy and we are happy. So we are done with our second sketch. So I press finish. Now I select extrude, reset. Now I select the sketch. And as you can see, this is the wrong direction. I want to extrude in the other direction. So I do a double click over here and I change this option from value to and next. And as you can see here, you can see the result. And I go from none to subtract and click OK. So the first of 3 holes is done. I go ahead with the second one. So again, select sketch. I choose this plan. OK. Now now I create a rectangle. No, it's a little bit confused. Yeah, I agree. Is a rectangle. First of all, a little bit of let's add the circle on the left side. and on the right side I snap the midpoint and the endpoint. All right. Then I do a little bit of trim. So I select this one. This one should be away. This one should be away. This one and this one. All right. I'm fine with the geometry. Now I have to do a little bit of constraints. So the first one is to center point from this center point to this center point. So it should be one, this one from here to here, the second one. And now this one should be then needs a relationship to the 0, 0 point. To realize this, I select this center point and this center point over here. No, I don't. Close. Select. Why I can't select the center point? Our problem is now that our center point is over here. We need the relationship between this point and this point. Maybe it's a good case to add another tool. Another tool is to do to project curves. Click on project curve. And now we would like to project this curve. So we select this one. Okay. Now this curve is in our sketch mode, but we don't want to work with this contour. So we convert this contour to a reference contour. So select the contour and press your right mouse and convert to reference. Now we should be able to link this center point with this center point. So let's try it. So now we are able to link this center point with this center point. Yeah, we have additional problems. So maybe we have to go with a rapid dimension. The problem is now closed. What happens now? Now the problem is that if we take this one, that is not the right value, because we need the distance from this point to this point. So no, sorry. So maybe now we can do it. So this is not the right way. Now we are on the wrong way. Sorry for this. So let's click on finish and let's delete this one. To do it on the right way, we have to select this plan. And now we are able to work conformably. So again, first of all, I create a rectangle, something like this, a little bit too big, a little bit too big. So again, a circle on the left side, I snap the center, the midpoint and the end point. I snap the midpoint and I snap the end point. Then I do a little bit of trim work. So this one away. All right. So then from here to here, from this center point to this center point, and from this center point to this center point. Now it works. And from here to here again. Now we have to modify the values. So this should be 85. This one should be 40. This one should be 10. And this one should be 40. All right. Now again, extrude. Change from value. Instead of value, I go with next, and from none to subtract, and here we go. Now we are done with 2 of 3 holes. Now the last one. For this one, again, I select this plan and I add this circle. Now I have to define the diameter of this, and it should be it needs a relationship between this center point and our 0, 0 point. Okay, and the relationship from this center point to this center point. And yeah, it's not possible. So we have to do it in our head because we can calculate this diameter. So from here to here, it should be 85. And the distance from here to here should be 30. From here to here should be 32. So take it easy from here to here. And now we have to calculate. So a double click here. So 85 minus 32 minus 40, and this. So the distance between from this to this center point is 13. I'm fine with the sketch, so I can extrude the sketch as well. So I select someone, subtract. I go with until next. Now I'm fine with my geometry, and as I already said, now we have a little bit it's a long history. But now we have the possibility to maybe a customer changes his mind. Now the customer don't want to have this hole. Now it's pretty easy for you. You can select this feature and the sketch and can press on delete and it's away. You don't have to modify your sketch, and so to do it on this way, it's a pretty easy way to modify your component. And as I can tell you from my experience and from my side, in the context of product development process, there are a lot of changes in the geometry, and so it's easy to work with the workaround as shown. So in this case, you can keep the overview, and it's much easier to handle some changes. All right. Do you have any questions to this workaround?
Yes, I have a quick question
Yes, of course.
on what difference between United and Nant? I mean, it basically the same thing.
Between both, can you please repeat your question?
The difference between United and Nant.
Nuns? Okay.
Yeah, and United.
Yes.
What is different?
Yeah. Let's take a look on it. So in this case, we have subtract. Now I change the option to none. Okay. And as you can see the contour of our section. And if we change the order from time step order to body order, then you can see we have two bodies. One body is the main body and a separate body over here. So both bodies don't know each other, so they are separated. This is the result of none.
Okay.
Now let's go with united. So I change from none to unite. And as you can see, I can't see the section. And if I switch to the body order, you can see we have only one body. So with united, he joined one body to another body.
Mm-hmm. So if we make a drawing, does it show the contour for the 2D drawing after finish the model?
Yeah, yes, he shows us the drawing, as you can see the drawing over here in blue. If you don't want to see the sketch, you can invisible the sketch. So if you click on the eye, then the sketch is invisible. And if you click again on this eye, you can see the sketch.
Mm-hmm. Okay. How about when the manufacturing process? So when if the, for example, engineer who drawing, he made a nuns instead of united. So what happens then? You got my question?
Sorry, I don't got your question.
For example, the engineer drawing the extrude part into nuns. But okay, so what happened to the manufacturing? The guy who make the part, he will understand. Okay, these two different things, two different body inside a part, or what?
So you are responsible for the manufacturing files, and if you would want to export, for example, a step file or something like this, you have to select your bodies. So maybe let's take a look on this point because it's a very important point. So at the moment, I have only one body, and let's change this option from united to none. I have two bodies, one body, the second body. So now I want to export my file. So I can click on File, Export, and then I can go with Step. Step is a quite popular export file. Now this dialog box is invoked. Press on Reset. And an important step is to select your bodies. So go to Data to Export, and then you have to go with, you have two options. So first option is to export the complete body, so both bodies, or go with this one, and then you can select only one body, and then only the one body will be export. And this is so yeah, I hope it is a little bit clearer now.
Yeah.
And the same procedure for the technology draftment. So we will take a look into the topic of how to realize drafting a little bit later. And if you create your view, you have to select your body as well. And so in this case, you have also to select this body, and in the drawing, you can't see the other body.
Yes, I got it. Okay, thank you.
Thank you.
I'm clear now.
All right. Are there any other questions? All right. The time is running. Maybe you have some time to do a second task by your own. So it's up to you to do this task. Otherwise, we will do this task in the next week. So I share my screen. I share my presentation. So the second task is to try the other. In other words, we did this exercise in the last couple of minutes. So you use the direct way. Now, in the next task, you should use the two-step ways. And yeah, it's up to you. I will upload this task in our team channel, and it's up to you to do this task today, tomorrow, however. And otherwise, we will see us on next Friday. And on next Friday, we will continue our script, and we will talk about advanced modeling. We will talk about how you can realize holds, how you can realize shellings, and many more points. So yeah, I'm really happy to see you next week, and I wish you a very great weekend and a very great week, and we will see us next week.
Yes, goodbye,
Thank
Martin.
you. Have a nice weekend.